Okay, in the last class, we have studied regarding intra AS routines. Okay, means within the autonomous system, we have studied about the two techniques. First one, do you remember? First one is the RIP, that is the Routing Information Protocol, and one more you have. Second one, do you remember the second one? Hello, is it audible, guys, or not?
Is it audible, guys, or not?
Audible?
Yes, sir, audible.
Audible, no? Okay, fine, fine. So second protocol we have seen is your OSPF. That is Open Shortest Path First. Okay, so these are two intra-AS routing algorithms or protocols, you can say intra. But now we are going to study inter autonomous system routing protocol, and that is nothing but your BGP, that is Border Gateway Protocol. Now let us see how those two are different than this. Okay, so already we have seen within intra means within the autonomous system, whatever we are making communication, that is only limited for that particular, that is we have already seen the example of autonomous college, means within the college they can use the rules and regulations. Okay, but now we are going out of the school. Okay, so one college and another college both are autonomous, and there they are going to be communicated. Okay, so that is what the idea here. Now let us see what exactly is inter AS routing algorithm is. It's our BGP, Border Gateway Protocol. So with this RIP and OSPF, we have the BGP is one of the inter autonomous system protocol. It is also known as BGP4, that is version 4, or sometimes BGP protocol in the normal. Then some of the basic operations performed by or the services provided by BGP are, these are the basic three things. So if you understood these three, so it will be easy for you to understand the next one. It is covering almost all the things. First of all, obtain subnet reachability information from neighboring AS. Okay, so here one autonomous system is communicating with other. That is what the idea of inter autonomous system. Is it okay? So here one neighboring autonomous system is giving information about another neighbor. There is another autonomous system. Next one, propagate the reachability information to all routers internal to the AS. Not only the neighboring routers, but not only the neighboring autonomous system, but the routers involved within that particular autonomous system, that is also information will be propagated, that is transferred, or you can say it is broadcasted. Then the third one is determine good routes to subnet based on the reachability information and AS policy. So along with that, which will be the best path? That is what OSPF. The open shortest path. You have to reach the destination with some least cost. That is also performed here. It will specify you the good route in order to reach that particular information to the AS policy according to the protocol that is AS is used. Okay. So these are the three operations, and same thing is explained in this next topic. Now let us see what is the basics of your BGP protocol. So first of all, it is mainly used for the intra inter autonomous systems. Means one particular autonomous system will be communicating with other. Along with that, it has to follow some policies. Okay, so that is what the idea regarding this BGP. Now, when we go for this communication of the BGP, that time we are considering about the internal as well as the external BGPs. Okay, that is where establishing the connection using TCP, that is connection oriented protocol, which is used along with this BGP, and there is a policy that you can see this diagram. So we have autonomous system 1, autonomous system 2, and autonomous system 3. Now how all the routers with these are communicated, this is what very important thing. That's why there is a we need to establish the connection, that is TCP connection we have to use. For that it is using this port 179. So this will be the port used by your BGP. Okay, so how internet protocol is using 8080, okay, and some web browsers they are using some 80 ports. Okay, similarly here also this 179 will be the port number used by this particular BGP. Okay, and there is one more concept called the semi-permanent TCPs. Now what is the semi-permanent TCP? So whenever there are more than two paths are available for from one router to another router, so whichever is the dynamically changing and its value can be optimized. Okay, for example, now 1A and 1B they can communicate with 3 kilometer. But what if 1A, 1D is 1 kilometer and 1B, 1B is 1 kilometer? So this path will be 2 kilometers, so this path will be 3 kilometers. So this will be the better now. So similarly here also we are making use of this particular semi-permanent TCP connections. Okay, so this is what the concept is used. Is the semi-permanent TCP connections. Okay, and after that there is one more concept that here you can see here eBGP and iBGP. So E stands for external BGP and I is for internal BGP. Now here the concept says the sessions. So what is session? Already we have seen. So session is something the client and servers are establishing the communication securely. Okay, and only the end-to-end communication will be taken place here. Okay, so that is called as sessions. So here the sessions will be established from within intra-autonomous system or outside the intranet system, or that is inter-autonomous system. That is depending on eBGP and iBGP. For example, if you consider the communication between 1A and 1B, that is called as iBGP session. See here, 1A and 1B, they are communicating, so this is called as iBGP sessions. Okay, then if I consider 1A and 3B, this connection, so this I will call as eBGP session. Okay, now whatever the intermediary routers are available, that is 1C, 3A, so these are called as intermediate routers, which will be called as eBGP sessions. Understood, guys? So first of all, you need to remember what is semi-permanent TCP. So the routers will change their values; they will upgrade themselves. In which technique you are changing this? In the distance vector. Yes, in the distance vector protocol, you are going to change it. So whenever there is a dynamic in the where they are dynamic in the state, that time we call the semi-permanent TCP connections. Okay, and after that we are making use of the sessions of the BGP. Whatever the internal things will be there, as iBGP sessions, and outside that we call it as the eBGP sessions, that is external BGP sessions. Okay, so this is about the BGP sessions. So this is the case study we have given here. Case study is just for the reference purpose we have. The next one, here is explained about eBGP and iBGP. We have already discussed in the figure 4.40. Okay. Now, next one, how to identify and how to make each and every node reachable. Okay. Now, I will again refer this diagram. So, what this diagram says? Now, 3A, if you want to communicate with 3B and 1A. Now, even not 3B and 1C I can say. So, 3B is not reachable for 1C, as there is one more intermediary router is there, that is 3A. So, we have to find 3A and broadcast its neighbors. Okay. So, 3A is connected with what are the other routers? 3B is there and 3C is there. So, this all information will be kept in this 3A, and this information will be flooded or it is sent to all the neighboring nodes. Okay, so 1C can say yes, I can communicate with 3B along with this 3A. Okay, So this is what the concept here. Okay, so this is what the case he has given the example. So how we are making each and every node is reachable with all the neighboring nodes. Okay, within outside the autonomous systems. Okay, so whatever the example we have seen, that is what 1B and 3B both are belongs to different autonomous systems. No, so how one particular node will identify the another node present in different autonomous system. That is the concept here given. That's for HMU. Okay, so the same thing with the example is explained here. Now the next one, we will go for the next. We have path attributes and BGP routes. So here, attributes means it gives some extra information regarding the autonomous connectivity. That is path. Okay. So in an autonomous system, if two or more number of paths are available, so which path is having what cost? Okay, and whether that path has some traffic and all, then all information will be taken place. Just wait. Sorry, let's continue. So here, so the path attribute means if there are multiple paths present from two systems, so how we are going to make it possible to communicate and give more information. That is what the path attributes. Okay, and what are the possible routes are there? That is also we are going to get that. So this is the topic we are going to discuss now. So here, for this to make this, we are making use of some extra notification that is called as autonomous system number, that is ASN. Okay, means it is not practically possible, but every BGP is making use of this ASN, which is used for identifying each and every node or the router present in this different autonomous system, not in the same autonomous system. Okay, for example, we have seen 1A, 1B, 2A. Okay, see these are what we have given the names. Similarly, the main BGP will also give the names for those all autonomous systems. Okay, then sorry, let's continue. Now, so this is what some attributes. So that will give you information for you along with this ASN. Now there are some attributes, important attributes. Attributes. There are two major attributes. What are those? One is AS path and one is next hop. So these are the two important. Now these attributes are specified using capital letters. Okay. So even for your system, there are some environment variables which will give you some system information that is also given in the uh, this one capital letters. So here also we are giving BGP attributes in some broader manner in this AS path and next hop. Now let us see what exactly is AS path. So this attribute contains the AS through autonomous systems through which the advertisement for the message has been passed. Okay. For example, uh, one of the router which is going to be self-advertising itself. What is the path required to connect to that particular system? That is called as AS path, autonomous system path. Okay. For example, in our case, so we are going with this particular example. We will take this example. Now here, uh, so this X and this one more say Y. No, sorry, this is A and this is X. So these two want to communicate. Now this path has to be identified. Now this X is present in the autonomous system 1 and A is present in the autonomous system 2. So in this case, the router intermediate node or the intermediate router will make the interflow of these two paths. Okay, so this is what we're calling as AS path. Okay, we are creating the path from the source to the destination. Okay, so this is what the AS path. Some example is explained that you can see this is one of the major attribute AS path. Now once the path is established, we have to find how many hops there are. Okay, that is next hop. So providing the critical link between the inter AS and intra AS routing protocol. Now if you consider this diagram, so what is interlink and intralink? So this particular link which connecting to AS1 and AS2 is called as inter-autonomous system, and the link will communicating with this and this. This is called as intralink. Okay, so this is what the second one, next hop. Now how many hops it requires? Okay, that is the major issue here. So this you can give the example y. This is x, this is y, and this you can use as a next hop. Okay. So here you can see here next hop. So the next hop is the router interface that begins the AS path, for which the source and destination are connected, and wherever there is an intermediate nodes or routers are available, that's called as next hop. So this next hop will be responsible for communicating between source and the destination. Okay, and then most of the time we are making use of external BGPs. That is because you are communicating with different autonomous systems. No, till now what was the concept? Intra autonomous system we were making communication, but now we are making communication with inter. One autonomous system is connecting with another, and you have to reach the required router. So how to make it? You just follow the first AS path. After that, whatever the intermediate routers will come, you have to find the next hop for them. Okay. For example, now I want to communicate Nipani to say some Bombay. Okay. So this path is very longer distance. So what I do, I will just inform that which will be the next path, next hop. Okay. So first I have to reach the Kolhapur. After that I have to reach the Pune, and after that I can reach the destination. So whatever this Kolhapur, Pune are there, that is called as next hop. Is this fine, guys? And what is AS path? Karnataka and Maharashtra, these are what? They are different autonomous systems. That is AS path. Are you getting, guys? So this is what the real-time example of the. These are some attributes of the autonomous system. The BGP protocol. Is this fine? Are you getting or not, guys? Yes or no? Does this respond? Yes or no? Getting or not?
Yes, sir.
Okay. Now, so this is the diagram. We have explained already what is intra and what is inter autonomous system. Next one. Now we have completed. So one more point is that is import policy. So when a gateway router, now in this case what will be the gateway router? So this A and this is say B. These are called as gateway routers, means which are situated at the end. Okay, that is called as gateway. So for these gateway routers, it uses its import policy. Now what exactly is import policy? Already we have seen. Now I am communicating with other autonomous system. So I have to adopt all the rules and regulations defined in that particular autonomous system. That is called as that is what the gateway routers. Yes. So they will adopt one of the rules and regulations protocol we can call, that is called as import policies. Okay. And that has to be managed or identified by this AS path, because both of them must be mutually understandable. For example, one of the examiner is external examiner is taking that 100 marks will be the final, and internal examiner will say it is 80 marks is final. So there should be some proper policy in between them. No, that is what the AS path will be established. Okay, means some common rules regulations are established in the import policy. Is it okay? Now this has to be adopted in the autonomous systems. Okay, so this is what the regarding two attributes. One is the next scope and one AS path. Okay. Next we will go for the BGP route selection. How the route selection process will be taken place. So for selecting the route, there are again two techniques used here: eBGP and iBGP, internal and external BGPs. Okay. Now there are again two consequences. One is to find the route within the autonomous system, that is by making use of internal BGP sessions, or sometimes outside the autonomous system, that is called as eBGP sessions, external BGP sessions. Okay. So how this path selection process will be carried out? Let us see. So here, four operations will take place here sequentially. What are those? So routers are assigned a local preference value as one of the attributes. Depending on the attribute, that is AS path and your AS path, you are specifying the value of this, and it is assigned to the all local nodes. Okay. For example, what is the difference between say Chikori and say Nipani? Okay, that is what the local preference and value will be stored. That is how you are preferring it using this attribute AS path. Okay. Then the local preference of the route could have been set by the router or could have been done by the another AS, that is administrator. Okay. This is the first operation, and all these are sequential orders operations. Okay. Second one, from the remaining routes, the routes with the shortest AS path is selected. Okay, it will find is there any shortest path available from this particular route. It will find if yes, so that will be set as the shortest path. The step number 3. Let us see. From the remaining routes, the routes with the closest next hop router is selected. Okay, if is there any shortest path available with Chikori and Nipani apart from the previous AS path, so we are setting that particular next hop. Okay, say intermediate that will be one path, so that will be the shortest. So it will be chosen as a shortest path using next hop. Okay, and the last one, if more than one route still remains, so the router uses BGP identifiers to select the route. That is, internal algorithm will select the appropriate that particular path. Okay, so these are the four operations takes place when establishing the or choosing the best path. It may be within the intra or it may be within intra or it may be inter. In both autonomous system, we are following these four operations. So there you may give a question, explain the four sequential operations for the four operations for the choosing the best path. Okay, so these are the operations you can explain here. Next one, there is again case study has given principles and practice. That is just case study is given. We'll not go with this. Okay. Next is the routing policy. How you are going to choose the shortest path, or what policy? There should be some policies, no? If two paths are there, why you have chosen only this particular path? Okay, that is what the routing policy. Now here the example here given A, B, C. These are the service providers. Okay, so you can say you are the service providers like Jio, Airtel, and all. Okay, so and W, X, Y. These are the customer networks. Now, how the communication will be established using different autonomous systems. Now, APC is actually they are provider networks, service provider networks, but they are also one of the autonomous systems. And even WXY, these are also customers, but these are also autonomous systems. So, how this particular communication takes place? how this particular routing policy will take place. That is the example he has given. Now here there are two different entities available here. One is the stub networks and one more is the service providers. Okay, so stub means what? Which request the service. For example, W, X and Y, they are called as stub networks. Okay, whereas A, B, C, they are called as service providers. Okay, so this is what the internal policy we have. So it's a simple BGP scenario. Now W wants the communication with X. So how many service provider it has to pass? Either go with A, B, X or A, C, X. Okay. So this is what the possible values you have. Now, how this selection of this one particular router will be taken place. For that, so this case study is after that, but it will give you some information. So policy, scaling, and performance. There are three major factors that causes to be one strong autonomous system. Okay. So strong case study is there. So this is also important for learning the next one. Now here, the concept called advertisement. Okay. So what exactly the advertisement is here? Now, whether this W and X both are both to each other, no, because two intermediate service providers or autonomous systems are present there. That's why they cannot be reachable to each other. Okay. So in order to make the advertisement, so just go on flooding the message X is connected with B and C and inform them individually. That is, we will be having that X is connected to C. Okay. Similarly, A will be sending that W is connected with B and it will send this information to B and C. Okay, now B will be updating its routing table by that is W has connected with A. And now it can communicate X is connected to B and W is connected with A. So these two are connected. So you can go communicating with this W and X. Okay guys, so this is called as flooding. Already we have seen this flooding concept. Yes. So this is what the operation takes place here. So same scenario we have explained how the communication takes place. Okay, A, B, C or A, B, Z and so on. And this is all about our discussion. So this part we will see next class. Welcome back to the multi-class. So I think up to here it is clear how the routing policies will be shared. So everybody is accommodating the routing table. Yes, already we have seen no, in the distance vector. So A is connected with these two means it will maintain two different tables. What are the possible routes need to be? What are the possible routes in C? Okay, so this is what the distance. That's why distance vector protocol and least distance protocol they are very important while learning these two. Okay. So I hope this is understood. How the intra-autonomous systems are connected and every router from that is connected. Okay. So that is what the concept is. Any doubts guys? Any doubts?